Okay, so you got this integral over here, as you guys can see, sine 6x plus 1 cosine squared 6x pi over 12. And you don't know what to do off the bat. So what I'll tell you to do is, you can see that you're going to have to do a substitution here. Now, what do you substitute? You're like, oh, do I substitute 6x? That doesn't, that wouldn't really do that much. Do you substitute 1 plus cosine squared 6x? That might be a little too much. Do you substitute just sine 6x? I don't know. That could work. But what if you just sub out cosine 6x, right? Okay, so I know everybody loves using u, so I won't use u. I'll use mu. And t is u. I'll use mu equals cosine 6x. Okay, well then we know that d mu is equal to negative sine 6x times 6, right? And dx. And let's write a little table here real quick, because now since we did this substitution, we got to change our coordinate bounds. So originally x, now we're going to mu. X was originally pi over 12 and 0. So you put pi over 12 into here. So 6 times pi over 12, that's pi over 2. Cosine of pi over 2 is 0. Okay, put 0 into here. Cosine of 0 is 1. Okay, so if I rewrite this integral, it's going to be 0, 1. Sine 6x is going to become mu 1 plus, oh, 1 second. That's not mu. Sine 6x. Cosine squared 6x is going to become mu squared. Okay, and let me put this guy a little bit closer here. And then what's our dx? Our dx, if we solve for dx, we would see that dx is what? Dx would be the same thing as d mu divided by negative sine 6x times 6. So if I put that here, I'd see that d mu is equal to negative, I'm going to put the 6 in front, negative 6 sine 6x. These signs can go away. And note that there's a negative here. So if there's a negative here and these bounds is from 0 to 1, like this in this reverse order, it's kind of unusual. Well, what happens is that if we were to integrate this, we'd get a negative. But if you want to switch this from 1, like put the 0 here and have the 1 here, you have to times everything by negative. So we're going to do that. We're going to switch it. But we also have a negative here. So if we do that and we have a negative here, then we're going to get a new positive integral. So it'll just be 1 to 0 d mu, 1/6 on the outside, and 1 plus mu squared. Okay. Now this is really nice to see, because if you guys see this right here, what does that look like? That looks like arctangent, right? So we get 1/6, and we get tan inverse of mu from 1 to 0, right? That's exactly what we see. And then we would see you get 1/6 tan inverse of 1 minus tan inverse of 0. Okay. So this is a nice answer. You could leave it there. Actually, that's an ugly answer. Don't leave it there. So let's draw the unit circle. Okay, so if we draw this unit circle, right, and let's just focus on areas that kind of relate to our bounds. I'm going to coordinate this 2 pi. The coordinate here, the angle is 2 pi. The coordinate it references to is 1, 0. How about this guy over here? This is pi over 2, right? And its coordinate it references to, that's a really ugly parenthesis, is 0, 1. And this coordinate over here, the middle one, right, at 45 degrees, that's pi over 4. And its coordinate is square root 2, 2, square root 2, 2. Okay. So the reason why I do this is because we want to find what tan inverse of 1 is and tan inverse of 0. So note that, remember, tangent of theta is equal to x over y, where, remember, this is like an x and this is a y, x, y, x, y, right? So in other words, we know that theta is equal to tan inverse x over y. So this is, we're going to use this relationship here. It's a really ugly y. That's x. We're going to use this relationship here to find what these are and represent these with just a finite angle instead of this because that looks kind of ugly, right? Okay, so tan inverse of 1. So basically, tan inverse of 1 means that we have to find an angle that produces 1. So in other words, tangent of what angle equals 1. And we know that the only angle that would correspond to this, right, would be, look, where it's goes square root 2 over 2, square root 2 over 2, and that's pi over 4. So let me explain that again if you didn't get that. Okay, so we know that tan inverse of 1, we don't know what that is, that's a question mark. But we do know what, if we take tangent pi over 4, we know it's equal to 1. So then we know the opposite, right? That if pi over 4, tangent pi over 4 is equal to 1, then we know that tan inverse of 1 must equal pi over 4. Okay, now we know what that is. Okay. Likewise, so we see tan inverse of 0. Tan inverse of 0, we don't know what that is directly, but maybe we know what something like this is, right? So what is the angle that will end up producing 0? Okay, so something like this might help. Okay, so tangent again is equal to sine over cosine. Sine over cosine. So we know that the cosine has to be 1, right? This bottom part has to equal to 1, and the bottom part has to equal to 0. So in other words, the x has to equal to 1, so it's 2 pi. So tangent of 2 pi is equal to 0, right? So cosine of 2 pi, what is that? That's 1, cosine 2 pi, sine of 2 pi is 0. So this makes sense. There we go. So now we can go back, and we can write our final answer in this nice green box. So we get 1/6. And it's going to be what? Pi over 4, because that's tan inverse of 1.